Now there is a more op-amp specs. Okay, there is a op-amp specs specification that I didn't actually talk about it, so I decided to continue with it. So what do I have is that if you remember, this is actually the rule 1 of my op-amp, stating that there is non-zero current. So that means there is no current flowing through the op-amp. Right? If you remember, there will be no current flowing through the op-amp. But realistically, you may have some current flowing through lah. Okay, so yeah, so this is the case. So this is the first rule states that no current has to flow through the op-amp. Now, what about the second rule? So offset voltage is the output when the input voltage is 0. What this means is that if you have an op-amp, there is a V in, right? V to plus, and there's to minus, right? There's a V out. So in this case, if you have a V in that is 0 voltage, right? If you know that there will be a feedback system to the negative side, right? Ensuring that this will also be 0 voltage, right? However, in this case, because the offset within the op-amp may have some situation that is like a bit weird, so this may actually feedback to 1 point, maybe 0.001 volt because of a certain system within it lah, right? Maybe some residual voltage stuck inside there. I don't know lah. Okay, I don't know. So end up this one may actually have come out 0.001 volt also, because it's the difference. It's the difference between them that comes out the voltage. So it's I don't know. I don't think it's a difference, but then nonetheless you have something like that lah. This is the meaning of it. And then so in order to rectify that, you're gonna have a potential applied to them. So you may have, if you remember, there is a supply over here, right? There's a plus supply and minus supply. So you may supply in some voltages in order to offset away this 0.001 volt in order to accurately measure some things. So this is a very vague explanation, but nonetheless, it does open up views of it. So the third one is actually okay. Third one is actually, let's say you have a, this is very abstract now. Okay, this is very abstract. I cannot explain anything much. But what it means is that when your input comes in, okay, it may have a very high impedance for some reason, okay. So if you were to exit from your op-amp, you will have ideally 0 impedance, right? So 0 impedance means that there is 2 explanations. I may be wrong. So one is that V equals to IR. If you have some impedance over here, maybe like 10 ohm impedance, some voltage coming in may be actually a little bit so-called diminish or amplify or changes because of a resistance change. Because if you have a resistor over here, so if you have a voltage in, right, and then because there is a lot of resistors inside the op-amp, so across the op-amp you may some whatever voltage coming out may be a little altered, right? If you remember, let's take a look. Let's say, imagine you have a voltage in, right, and you have some resistors. Because if you remember, the op-amp itself is a very huge amount of voltage, like resistors also. So in order to change, to ensure that the voltage out is equals to the voltage in, you're gonna ensure that the configuration here gonna have 0 impedance in this case, right? So but nonetheless, when I was taught, okay, is that V in may have a high impedance, and then V out must have a low impedance. So op-amp itself states that high impedance in, low impedance out. So you will have you can actually push out a lot of voltage of this section over here. That's all. So this is how I memorize the video on that. So this is, but in real op-amps typically it's 100 ohm. So ideally 0 output impedance, but ideally realistically 100 ohm. So this is the specs, right? So the slew rate represents the maximum rate of change, right? The maximum rate of change of a signal at any point. So so you may have let's say you something like that, right? And then suddenly it may, what am I drawing? Let's say you have a signal like that, and then suddenly at the next point it goes down like that. So the change in this is so called a slew rate lah. Okay, I may be wrong. Okay, this is the slew rate. Okay, the change in the amplitude across time. This is a better explanation than mine. Okay, so just cancel this loop. Okay, so it is the change in this thing divided by time. That's also you're gonna take this one and then divided by time. Alright, so typically is expressed in volt per 10 to the negative 6 seconds, right? But nonetheless, you may also say that 1 volt over 10 to the power 6 seconds minus 6 seconds, or to 1000. So the range, okay, the range is from 1 volt minus 6, 10 to the minus 6 seconds to 1000 volt divided by, so it's a very small change in seconds lah, right? So because everything happens so fast, right? So for signal with frequency f, we require a minimum slew rate, so as minimum as possible. So 1 volt is the best one in the sense, right? So 2 pi f times the v peak, right? 2 pi f times v peak. V peak means that it's the highest point at this point of time. So the slew rate is that so if you want minimum, this means that you want at least over here only. So if you have this over here, you will have lesser slew rate, meaning lesser changes lah, right? So to give you a clearer view, alright, this slew rate and this slew rate, which is better? Which is the preferable one? It's actually this one. Alright, minimum slew rate times, so 2 pi f times the v peak. So if your v peak itself is low, you'll have a slew rate that is low, right? So this is why you have a minimum slew rate. If your v peak is so high, you're gonna have a very high slew rate. So this means that you have a very huge change, rate of change of your signal. So your signal is very unstable because you want the signal to be very steady state, right? But however, if your signal is keep changing and changing, it's not very stable at all, right? It's just like doing. So this is the thing he's talking about lah. And nonetheless, I may be wrong, but this is the op-amp specs of the thing. So maybe I should hold on. Alright, and please take note that this slew rate for minimum slew rate is only if you have a frequency. Alright, for signal with a frequency, then your minimum slew rate, then you have, is required to have a minimum slew rate. Alright, if you have maybe not frequency, okay, if you take a look for the ideal op-amp, slew rate now is ideally infinity. I don't know what the fuck. Yeah, here say minimum, and then here say infinity. So who do I trust? So in this case, to protect yourself, you may say that minimum slew rate is frequency, right? For frequency signal, you're gonna have a minimum slew rate. For other case, slew rate ideally is infinity lah, right? So in order to do that, I actually do it out this one. For infinity, for ideal op-amp, right? Ideal op-amp. What is infinity is how I memorize it. Okay, is that I memorize in terms of the alphabets. Okay, bigs means infinity, right? So this is bandwidth, this is input impedance, this is gain, and this is slew rate. So bigs means infinity ideally, alright? And then ideally no means 0. right? Zero. Ideally zero. So noise, your output impedance, and your offset voltage. So it is somewhat like more easier to memorize, like melodics, something like that. So yeah. So in other words, if it's ideal op amp, you will have bigs and no, alright. And then if it's non-ideal op amp, then you flip lah, alright. So this one will become zero, not now, okay, not infinity, and then not zero. Let's say not lah, okay. So this is the key thing that I want to convey over here, and then I think that's all. So I'll see you when I see you. Bye bye.